Okay, welcome everyone to the Nazarian Center for Israel Study, the UCLA Nazarian Center. And we have a special webinar today. And this webinar will focus on transboundary water sources in the Middle East. This webinar is co-sponsored by the UCLA Department of Geography, the Institute of the Environment and Sustainability, UCLA Water Technology Research Center, the UCLA Center for Near Eastern Studies, and the UCLA Center for Middle East Development. Today's seminar will be attended by individuals from over 15 countries. So we really appreciate that level of interest in this important topic. And I do appreciate the director of the Nazarian Center for Israel Studies, Steve Zipperstein, for asking me to introduce our speaker and to moderate this webinar. Our speaker today is Professor Elon Adar, and Professor Adar is from the Zuckerberg Institute for Water Research at the Jacob Blaustein Institute for Desert Research at Ben Gurion University at the Sde Boker campus. Professor Adar is a well-known, internationally recognized hydrogeologist and founder and leader of water research activities at Ben Gurion University at the Sde Boker campus. And he is, among his distinctions, is that he is a graduate of the Hebrew University of Jerusalem and also a PhD from in hydrology from the University of Arizona, our neighbor not too far away from LA. He is the founder and director of the Zuckerberg Institute for Water Research. And I've known him for about 20 years, benefited from his vast knowledge regarding water resources, not only as of today in our era, but also in ancient times. And I can go on and on to describe his critical contribution to science, but I think that more appropriate is to say that he played a pivotal role in establishing Israel's leadership in arid zone water science, and he was played a formative role in advancing Israel's national approach to seawater desalination, to deal with various issues of water sustainability, understanding basic principle and integration of groundwater management. And what is really important and linked to today's talk is his experience at the international scene and his key role in serving as a member of a technical committee or chair of a technical committee on water issues in the peace negotiations with Jordan and other areas in Israel. So I won't say much more and turn over the microphone to Professor Adar. And just to let you know that at the end of the presentation, there will be a Q&A session. And please put your questions directly into the question, basically button that you will see. Click, write it down, and we will go through those various questions. So without a further ado, Professor Adar, the mic is yours.
Thank you, Yoram. It's my honor. Small correction. I was not the chair of the peace treaty negotiation regarding water, but this is not the main issue. It is my privilege to present you today what I face and deal with for a couple of years now regarding the transboundary water resources, not just in the Middle East, but in other places around the world. But definitely I will dwell on what we face in our region. So, as it says in the title, water knows no borders. Transboundary water resources in the Middle East. This issue people used to claim that it will be a trigger for a conflict, and I would say right now that, as you may guess, I'm the one that believe that it is a catalyst for collaboration and cooperation. I think this is the reality despite of all the hostility going on in the region. So let's start. How important it is. So water and food are significant elements in homeland security. That means that water becomes, I mean, in my opinion, is a synonym for food and vice versa. And as I said, the main issue that I will address during this presentation is to find out whether or not it's really a potential trigger for a conflict or a catalyst for regional cooperation or collaboration. Let's start. You can see here in the satellite image that we are in the world desert belt. We have the Nile Valley right here, and the delta of the Nile, Sinai Peninsula, the Negev Desert, and the Arabian Desert. Here is the dying Dead Sea. It's all yellow or brownish, indicating we are in a desert. Water consumption in such a region exceeds the safe yield. So demand and actual consumption of water is far beyond the natural rate of replenishment by rainfall. Therefore, having said that, water in the Middle East is a scarce resource and beyond, because it is so important in the region. It is a scarce commodity, as you can see here, as natural gas. And it is unusual worldwide, but in the Middle East, both Palestine and Jordan, and including the Palestinian Authority, deal with water as a commodity, not just as a natural resource. Israel, in order to bridge between demand and supply, Israel moved in the year 2004 for massive desalination of seawater, of Mediterranean water. Before that, we established several desalination plants for brackish groundwater, and that was, and still is, our way to bridge between demand and supply. What you see here is the most modern desalination plant with vertical cassettes in the Sorek plant, and this is going to fulfill what the Jordan River, that what we see in the lower photos, cannot supply any longer due to climate change and decline in the natural discharge. So water from natural sources is an economic anchor on which the state of Israel relies, despite the fact that we desalinate massive amount of water. Still, as a backup system for our water supply, we rely on the natural resources. Now, having said that, all major water resources in the region are transboundary or cross-border water resources. I mean, we start from, let's say, what we see here on the right-hand side. We start with the Euphrates and the Tigris, starting in Turkey, flowing through Syria and Iraq down to the Gulf, the Persian Gulf. The Nile, 9 more countries actually sit and enjoy the water on the upstream Nile Valley. Egypt is the major used to use the major amount, but not anymore, as we shall see later on. And of course, the Jordan River in the Near East. It is the border, international border between Syria and Israel, Jordan and the West Bank, and so on and so forth. I mean, Lebanon, Syria, Jordan, Israel, and Palestinian Authority share the Jordan River basin. Now, water and food are significant elements in homeland security, already said so. What we see here in our region, because most of the fertile land has been already taken, cultivated, we were forced to move into arid basins and start cultivating the deserts to produce enough food. In the left photo, these are the pivot irrigation in southern Jordan in the DC basin, used to grow barley and wheat. In Israel, we don't grow much grain on irrigation. What we go into more cash crop crops, and we see in the Negev highland vineyards producing grapes and wines export mainly in Europe, and the wine all over the world. We are not the only crazy ones, that moved to cultivate desert land. An example that I was involved with in Kazakhstan, along the Ili River. The Ili River crosses from the Himalaya ridge, the Kazakhstan desert into the Balkhash Sea. And what you see here, diversion from the Ili River for irrigation to cultivate rice plots over the sand dune terrain, and with, I would say, good yield but low irrigation efficiency, and even alfalfa in the desert. Well, I don't understand why it is okay. With this short introduction, when we deal with cross-border water, when we deal with rivers, surface water, I mean, it's easier to measure and easier to decide on how to divide the water, because it's easier to measure the quantities and identify precisely the boundaries between the basins. The coastal area, the Jordan Rift Valley, so on and so forth, because these basins are defined by the geographic structure of the area. So when we deal with sharing water of rivers such as the Rio Bravo, Rio Grande between Mexico and the United States, or the Jordan River between Israel and Jordan, and nowadays, I mean, we know the quantities, and we can quite rely on solid hydrological parameters and facts. This is not the case when we deal with groundwater. What we see in this slide is the so-called hidden deep groundwater, the aquifers, underneath the Sahara, eastern part of the Sahara, in the western desert of Egypt, the so-called the light blue clouds here, the big Nubian sandstone aquifer underneath the Arabian desert. We have a portion of that also underneath Sinai in the Negev desert. The stars that we see here are places where I would say conflicts on water were emerged. For example, between Turkey and Syria, Syria and Iraq, between Egypt on the Euphrates and the Tigris, between Egypt and Libya about how to use and how much to pump from the shared aquifer, the Nubian sandstone aquifer underneath the eastern Sahara or western Egyptian desert, between Hashemite Kingdom of Jordan and Saudi Arabia regarding the DC, and later on we shall dwell also the disputes about the Jordan River between Israel and Syria, and how we reached an agreement between Israel and Jordan. Also, a bit we shall, I hope time allows, also to deal with or to describe the situation regarding the aquifer in the West Bank between the Palestinian Authority and Israel. Okay, when we try to find out what's going on below surface, okay, let's see. The mountain aquifers in Israel, the mountain aquifer shared between the Palestinian Authority and Israel is, of course, cross-border water resource. The same is with, as we can see here, with the Azraq aquifer. In this particular case, it has been used by the Hashemite Kingdom of Jordan to supply water to Amman, and it turned out that it is replenished over the mountain in southern Syria, Jabal Druz or Jabal Arabs. The deep eastern Nubian sandstone aquifer is shared by Israel and Egypt. It's replenished in Sinai, flowing through Sinai, through the Negev, and discharged into the Dead Sea Valley, Valley. The coastal aquifer, well, it's obvious, Israel and Gaza, Palestine, and the Arava, between the Red and Dead Sea, the Arava Valley. This aquifer is shared by Israel and Jordan. By the way, I think this is the only aquifer in the world that has been agreed in how to share the water between the two countries, and it is part of the peace treaty between Israel and Jordan. And finally, the DC aquifer, which is shared between Saudi Arabia and the Kingdom of Jordan. Now, what you see here, these are the trajectories, the general trajectories of the flow within these aquifers. All are across international borders, but these trajectories, their location, their magnitude, the discharge along them are not yet well established because it is so-called hidden from far below surface. There are two models, two type of models. I would call it extreme attitudes for transboundary water management. I will take two examples. One example is from the Euphrates and the Tigris. I call it type 1 model. And this example, I would declare it and say that, or those who are in favor of this attitude, they claim that geographical sovereignty confers sovereignty over water. Yep. What we see here is the Eastern Anatolia. We see here on the horizon the Black Sea, and here close to the Syrian border we see a huge reservoir, which is the Ataturk reservoir behind Ataturk Dam. This is the upper dam, one of 7, but the biggest one on the upper Euphrates River. If we review it and see, if we see it on the map, here is Ataturk Dam, and just not too far below, just across the border, there is Lake Assad, another big reservoir which depends entirely on the water which is released out of the Ataturk Dam. Well, here we see it. Here is the Ataturk reservoir, here is Lake Assad, and it is well known that the entire irrigated cultivated area along the Euphrates relies on the goodwill of Turkey to release water from the Ataturk Dam. On the other side, Syria, or the northwestern Syria, they rely on water coming from the Urantus. So all the irrigated land, all the food basket of Syria relies on water which is replenished or coming from nearby countries. We shall later on discuss it further if time allows. Okay, the second extreme model or attitude for transboundary, I call it type 2 model, is that actually those who claim those who are in favor of that, they say adherence to water rights, to historical long-term water consumption. And of course, the best example is the Nile. The Nile was the major source of water, or has been the major source of water for, several thousand years now, supporting the Egyptian civilization. And Egypt claims that although they are on the downstream side of the Nile, they would like to guarantee that the entire amount of water that they used to accept or receive will be maintained. Of course, this is not the case nowadays. They constructed, the British constructed a small dam in the 30s, the previous century. Later on in the 60s, mid-60s, using the resources from the former Soviet Union, they constructed the biggest dam with a huge reservoir in the middle of the desert. The capacity is about 130 cubic kilometers of water. Huge amount of water. For what? To control the floods and maintain the floods water inland to be used in the dry season instead of letting the water running into the Mediterranean. Now, this amount, here is the lake in southern, it's Lake Nasser, in southern part of Egypt. It's actually touching the border and across the border with Sudan. It is located in the middle of the desert. A conservative estimation assess the rate of evaporation from 10 billion to 16 billion cubic meters a year lost from the lake or from the Nile every year. This is about 16% or 17% of the total consumption of water used in Egypt, mainly for irrigation, but not only. However, they insist that they will get enough water, whatever it takes, into Lake Nasser, and of course, they use the water very wisely. This water, or the storage of the water from the flood season into the dry season, allow them to cultivate the Pium Basin, to expand the cultivated area in the western desert. We see it right here, beyond the borders, the western borders of the delta, and also the eastern desert. So they use the water very wisely, and they insist that they need all the amount to support what they already established. Now, the main water source of the Nile, we know, is the Blue Nile through Ethiopia highlands, and the White Nile crossing, 8 more or 7 more African countries. And the White Nile and the Blue Nile merged together just south of Lake Nasser. The Ethiopians insist of constructing their own storage on the Blue Nile. For years, Egypt objected and didn't let them do so. Now, after a long, dispute, and finally they reached a kind of agreement, the Renaissance Dam has been completed with a huge storage of water, not 130 cubic kilometers, only 87 cubic kilometers, and they let it accumulated during, not in 1 year, otherwise Lake Nasser would almost get dry, but in, I would say, 6 to 9 years, slowly but surely they accumulated this amount of water. Similarly, on the White Nile, for years, Egypt objected and prevented Sudan from constructing the big Rosarius Dam. I would say 6 to 7 years ago, they finally reached an agreement to let Sudan do it. Egypt realized that the upstream users also have rights to the border. So these are the two extreme models. Now, getting closer to our region. Here we have some disputes between Syria and Jordan over the Yarmouk River. Dispute between Israel and Syria about the water coming from the Hermon aquifer. Dispute between Israel and the Palestinians regarding, as I said, the mountain aquifer, the eastern and the western one, about the coastal aquifer. What we had some kind of arguments with Jordan about the Arava aquifer, and between Jordan and Saudi Arabia about water in the DC. Now, let's start with the Jordan. Bear in mind, the Sea of Galilee, here is the Golan Heights. The Sea of Galilee is the major and the only fresh natural lake in the entire Middle East. It is located entirely in Israeli territory. However, the water is feeding the Sea of Galilee, coming from Lebanon, Syria, and then it's flowing further down between Israel and Jordan, Palestine and Jordan. Okay, as I said, it is the only natural reservoir in the entire Middle East. When we look at the hydrology of the Sea of Galilee, it is situated, it's about 210 or 12 meters below sea level. It's all replenished by 3 major springs coming from the southern edge of the Hermon mountain and the Hermon aquifer, Jurassic limestone. flowing through the Hula Valley down into the Sea of Galilee. So the upper Jordan River, fed by the Hermon aquifer, I repeat, fed by the Hermon aquifer, sustain the flow into the Sea of Galilee, the major freshwater reservoir historically for Israel, nowadays, as you will see, also for the Hashemite Kingdom of Jordan. Now, all is coming from the Hermon mountain. Snow and rainfall over these high mountains infiltrates into the bare limestone, Jurassic limestone, feeding the aquifer into the east toward the Damascus Basin, toward the south to the spring of the Banias and the Dan, and towards the southwest into the Chatzbani in Lebanon, still flowing into the Jordan River. All these three springs, the Banias and the Dan and the Chatzbani, feeds or serves as the major source of the upper Jordan River. These are the general flow trajectories, as you can see here. And this is the mountain covered with snow, and this is the major source of recharge. All the recharge of the water feeding the upper Jordan River are outside of the territory of Israel. And as I already said, Israel rely heavily on the Jordan River as the major source of our national water carrier, conveying water from the Jordan River or the Sea of Galilee, fed by the Jordan River, toward the central and the southern part of the country. More rigorous map showing here. You see, the southeastern flank of the Hermon Mountain feeds Damascus. The Barada Springs that feeds Damascus and Damascus Basin. As I said, water from the Hermon flows also underneath the basalts of the Golan Heights into the Yarmouk River. I will talk about it later, and feeds the major springs, three springs of the Jordan Valley and the Jordan River. South of the Sea of Galilee, there is a Yarmouk River. The Yarmouk River feeds also by water coming from by groundwater coming replenished from the eastern or southeastern part of the Hermon, from rainfall falling over the Golan Heights, but also from Irbit Plateau in Jordan. Now, this is a nice historic photo. Here we see the Yarmouk, the flow in the Yarmouk. The Yarmouk, as I said, if I didn't say it, I would say it now. It's unlike the Jordan River, which the major source is springs. The Yarmouk River feeds mainly by runoff, by floods coming from Irbit Plateau and southern Syria, Hachoran and the Golan. What we see here is the Yarmouk River and the so-called the picnic table sites, hidden negotiation between Jordan and Israel under the radar. So the Arab League will initiate the Hashemite Kingdom of Jordan for negotiating water affairs, splitting water affairs between, or sharing water affairs between Israel and Jordan, the water from the Yarmouk and the water from the Jordan River. Unlike the Jordan, as I said, that relies mainly the Jordan River fed by springs, the Yarmouk feeds mainly by floods. That means that in order to use the water, they had to construct a dam. At that time they did not have access to the Sea of Galilee, to use the Sea of Galilee as a natural and artificial reservoir for storing water from wet to dry season. They had to construct, they call it the Wachta, or the Unity Dam or reservoir over the Yarmouk River. Once they started to construct it, they realized that suddenly the amount of water, the discharge in the Yarmouk dropped dramatically. If we look at this satellite image, here is the Golan Heights, we realize that many, many reservoirs have been constructed by the Syrians in southern Golan. As we see here, 19 dams were constructed on the tributaries of the Yarmouk River. The Jordanians constructed additional 7 and actually they decreased the discharge flowing into the Yarmouk River, and therefore they realized that it doesn't make sense to complete the the reservoir. They came up with a very small reservoir, and the Yarmouk winter water surplus is now diverted into the Sea of Galilee following the peace treaty between Jordan and Israel. Yes, every excess of water not captured by the Jordanians for irrigating the Jordanian side of the Jordan Valley is now diverted through a pipeline, 8 kilometers pipeline. That's it, 8 kilometers, and stored in the Sea of Galilee, and it is given back by gravity to Jordan in the summertime. Well, this is the agreement, the peace agreement signed in 1994. So to sum it up, okay, summer water supply, winter water surplus diverted into the Sea of Galilee and later on released in the summer to Jordan. However, according to the peace treaty, Israel also obliged to provide Jordan with additional, no matter how much they stored, additional 50 million cubic meters in the summertime in return to what? In return to the permit provided by the Jordanians to Israel to continue obstructing groundwater in the Arava Valley. The maximum of 20 million cubic meters a year. What a deal. I mean, Israel get 20, in return they supply 50. Nowadays, by the way, we supply 100. What a deal? Yes, it was a deal. Because at that time, in order to divert water from the national carrier of Israel, 20 million, into the Arava Valley, the value or the cost would be equivalent to 50 million cubic meters of fresh water from the Sea of Galilee. Yes, trading of water, groundwater from the cross-border Arava aquifer in return for water from the Jordan River. Let's continue. Here again, these are the point of conflict, and I would like now to dwell on the DC aquifer. When I talk about the DC aquifer, where is the DC aquifer? Southern part of Jordan and northern Saudi Arabia. You see here many, many green dots, and I will zoom in. There are hundreds of these pivot irrigation fields. That means every circle has its own well, pumping water from the Nubian sandstone aquifer that considered to be a fossil so-called aquifer. I hate to use water are never fossil, but old, very old water, not replenished nowadays. And look what happened. On the Jordanian side, here is the DC basin on the Jordanian side in 1985. They used to grow barley here, wheat and barley. Barley they used to sell for the beer industry in Ireland and Great Britain, and wheat they used by themselves. And look, the same, here it is. You see this outcrop here, and you see this here. This is the same photo taken in 2004. All these fields dried up simply because the pumps were left hanged above the water table. What uncontrolled water obstruction by both Jordanian and Saudi Arabian lowered dramatically the water levels, and you see what happened if you don't control or manage it in so-called in adequate way. The mountain aquifer. The mountain aquifer shared between Israel and the Palestinian in the West Bank. These are the flow directions. We see that water flows below surface from the outcrops of the limestone outcrops, Samaria, Judea, Hebron Mountains, westward and eastward. Regarding the western part of the aquifer, these are the wells that drilled starting even under the British mandate controlled Palestine until 1948. They started drilling water into this aquifer in the western side. And if we zoom in, we see that they also support the springs in the eastern part and the so-called Valley of Spring in Israel, in Israel. Well, yes, as you can see here, water from Samaria support all the springs in the Valley of Springs in the southern Jordan Valley right here. And the same water replenished over the dark green outcrops of the limestone that flowing westward support the two natural springs seeping out in Israeli territory, west of the Green Line. And nowadays, many wells on the Jordanian side, many wells on the Israeli side actually pump water from the same water reservoir. Now, these water flowing west used to seep in these springs. Nowadays, these springs, this is the Arcon spring or Uja spring, dried up because of heavy pumping on the Israeli side and on the Palestinian side. I may say that despite the collapse of the Oslo Accord between the Palestinians and the Israelis, the only active committee is still the Water Committee. We still talk, we still negotiate. Practically speaking, we reach an agreement how to utilize this aquifer, mutually manage this aquifer. However, Israel, well, I don't want to say for good or bad, Israel do not agree to sign this agreement. They say that the water will be part of the global agreement yet to be signed between Palestine and Israel. It's not only about the amount of water. Over these green outcrops, this is where the rainfall recharges the aquifer. So we are very much concerned about the quality of the water, not just the amount of water. Here we see the polluted rivers flowing from Samaria Mountains, Judea Mountains westward and eastward, with polluted because of maltreatment of the sewage water, not as we do now, diverting the sewage from the western Jerusalem, treated effluents for irrigation in the northern Negev. Okay. We reached almost the end of this presentation. As I said, we bridge the gap between demand and supply by desalination. We nowadays, since the year 2019, Israel desalinate almost more than 650 million cubic meters a year. Next year, it will jump to almost 750, almost 755, due to the construction of the 6 mega plant desalination plant in the northern part of Israel. So we rely on producing new water. We reclaiming effluents and desalination in order to close the gap. That means, or does it mean that we can ignore or give up on natural water resources? Not at all. We have to maintain not just the amount, but mainly the quality of this water. Now, the population in the Middle East will increase as it increases now, unless, God forbid, catastrophe occurs. That means more food will be, we shall have to produce more food. We shall have to provide enough water for domestic use, for the agricultural sector. All will come from desalination, produced water. We use maximum, 100% and beyond of the natural resources. When I say beyond, that means we mine water. We borrow water from nature, from the natural resource reservoirs, mainly from the groundwater, hoping that good years will come and we shall be able to pay back to nature. That means we need a lot of energy. For every cubic meter of water, we need about 3.5 kilowatt hour of electricity. And nowadays we use natural gas, which is better than coal or crude oil, but still, contributing to the global warming. There is a lot of pressure in Israel and from, around the world to move toward green energy. We have solar farms in the Negev desert, and we produce only about 18% of our total energy. Unfortunately, we do not have enough land. And here is the solution, in my opinion, and it's also official opinion of Jordanians and Israel, because we signed a treaty, unfortunately not yet materialized, that in the Jordanian desert, between at the west of the meeting borders point between Iraq, Saudi Arabia, and Jordan, even the Bedouins do not live there. Over there, huge, mega solar production power plants will be constructed. The energy will be sufficient not just for Jordan, but also for Israel and Palestine, buying green energy from Jordan. In return, Israel will desalinate Mediterranean seawater and deliver it to the Hashemite Kingdom of Jordan and to Palestine. Well, there is, of course, a fear of economic dependence. How to prevent the situation where one party to the agreement withdraw from the strategic deal. I think that the model that we already practice regarding the natural gas should be adapted also for water in return for green solar energy. Israel sells Jordan or provides Jordan with natural gas. Jordan, just to guarantee that Israel will never stop doing it because they lay down the foundations of advanced energy based on advanced industry based on this relatively cheap energy. They wanted to make sure that Israel will continue no matter what happened to supply it. So an American company was established and they deliver the natural gas from Israel to Jordan. Well, here maybe something similar can be adopted because it is very important. We shall be soon accused for contributed substantial CO and CO2 to the atmosphere if we keep producing more and more desalinated water. As I said, every cubic meter consumes 3.5 kilowatt hours of electricity. Well, I say, until recently, that was the attitude. Vanity of water or water arrogance, I would say. Everything is mine, all belongs to me, or the stronger takes as much, he wants, comparing to the to its neighbor. This has to be changed. This has to be changed. For development and management of cross-border water resources, there are two options. Zero-sum game, non-coordinated management, competition, and a cause for a conflict. Or win-win situation, according to my definition, efficient water management, adequate and sufficient water quantity and quality. It is not just the amount of water, it's the quality of water, coordination. This can be a catalyst for collaboration. Let's share and enjoy water, but for this, we have to change concept. From water rights to rights to water. And it's not just playing with the words. I mean it. It means a sufficient amount of suitable quality of water for everyone. Rights to water, this is what we should look for. And as I published already in 2003, it's only up to us to select conflict or peace. We can choose. And the ball of flags, it is not just a simplified logo. I mean it. We have to share, we have to coordinate, we have to study together, manage it together. Otherwise, it will lead to a catastrophe, in my opinion. So thank you very much. And I hope I'm willing to accept questions in case you have.
Thank you, Elon, for a great in-depth presentation of the situation in the entire area in the Middle East and beyond regarding water and the situation between countries when it comes to shared water resources. We have quite a few questions, and although I was going to start and ask one or two questions, it seems that the questions that I was going to ask are actually parallel a few of the questions that we received from the audience. So I'll take this opportunity and start with those. There was one of the questions is with regard to the shared resources between Jordan and Israel, and specifically with respect to water desalination, the Red Dead project, its scenario, where is it standing? Why has it not moved forward as initially envisioned? And how does that affect the situation of shared water resources between Jordan and Israel? So I'm summarizing actually the equivalent of three questions that were asked.
Okay, I would select, I prepared, I'm prepared and I selected, I'm trying to reach one of the slides this one. First of all, let's confirm Israel and Jordan started to coordinate, I emphasize coordinate, the abstraction of water from the Jordan Valley starting in the late 50s, beginning of 60s. We decided already in 1953, we, the State of Israel, that in order to be able to increase food production in Israel, we have to cultivate the northern Negev. For that, we need water. The only source of water is the Jordan River. In order to ease on the expected dispute between Israel, Jordan, and Jordan about the water, President Eisenhower, he sent to Israel his special ambassador named Eric Johnston. He was a famous guy in the movie industry in Hollywood, but he was also an ambassador, a diplomat. And he studied what is available and they came up with the so-called a pattern of how to share the water between Lebanon, the Jordan River water between Lebanon, because part of the water comes from Lebanon, the Hatzbani, Syria, most of the water, or all the water comes from the Hermon mountain, and at that time Israel and Jordan. Jordan at that time controlled the West Bank, so he also came with the idea how much Jordan will get, how much Israel will get. Luckily, they found out that the discharge into the lower Jordan River coming from the Yarmouk, and the Yarmouk is coming from the east between Syria and Jordan, is almost equivalent to the water coming from the north into the Sea of Galilee from the northern part from the northern Jordan River. About 300 million cubic meters, 350 million cubic meters on the average. Some good years provides more, some bad years provides less. And he suggested Jordan will get the rights for the Yarmouk River for almost 95%. Israel, out of the total average, will get less than 20 billion from the Yarmouk. In return, Israel will get the water from the upper Jordan River. Syria will get small amount, about 35 million, and the same Lebanon, for southern dry Lebanon. Israel accepted it de facto and de jure. Jordan accepted it de facto. De jure, they didn't want to do it because they were criticized by the Arab leagues. If they would accept it, it means recognizing the state of Israel. I'm talking about, late 50s now, early 60s. Jordan, Lebanon and Syria objected it completely. Israel decided, okay, let's negotiate with Jordan. And I showed you the picnic table negotiation site, in a nice eucalyptus orchard in the Yarmouk, not far away from the Yarmouk River, not far away from the Sea of Galilee. And we agreed, let's Jordan and Israel will start the diversion. They will divert water into the eastern part of the Jordan River. We shall start diverting water from here at the elevation of plus 70 meters above sea level by gravity into our national carrier. Well, at the beginning, even we got support from the United States of America for doing that, until they realized that the Jordan is an international border. And if it's international border, well, you have to get an agreement of your neighbor. The Syrians refused. and it was kind of a dispute. If I go to one of the, you see here, in the, in the 1954, Israel started the construction of a diversion dam into a diversion canal from the Jordan River. Now Syria claimed, hey, you take water from the Jordan River. It's international border. We do not agree. We even proceeded constructing the diversion canal, paving it with concrete. Well, and at that time, as you can see here, from plus 70 by gravity through a tunnel into our national carrier. United States of America pushed Israel to abandon the diversion canal. Now we know, they were really, the United States at that time, they said, okay, Mexico is now trying to get more water from the Rio Bravo, Rio Grande. If we support Israel to divert water from the Jordan, which is a border, Mexico will also have the rights to divert water from the Rio Grande. So, guys, abandoned it. And indeed, Israel stopped it. And we went into Plan B. Plan B, extremely expensive. This just provides you with how important the water was for us. We actually forgot about taking the water by gravity and started construction, the construction in a bunker of pumps, mega pumps, manufactured at that time in Germany and Switzerland, pumping water from minus 200 meters below sea level to plus 45 meters at a capacity of that time of 350 million cubic meters per year. Do you know how much energy it takes? That provides you with, or gives you the notion how important it was for us. So we did it, and at the same time, Jordan quietly diverted the Yarmouk River into the so-called the eastern part of the Jordan River, converted it into a food basket for Jordan. And our national water carrier diverted water into the Negev, and the rest is history. So we collaborated. The peace treaty between Israel and Jordan, although the last chapter agreed was on water, and I will not get into it, but we were quite ready and experienced how to deal with that, telling you that, yes, you have to compromise.
The question is with regard to the water situation in Gaza, and specifically with regard to also shared aquifers between Gaza and Israel, between the West Bank, or I should say the Palestinian Authority area, and Israel. How does that affect, what is the situation now, and what are the prospects for the future, and specifically for improved cooperation and collaboration? And where does technology comes into here? There are some questions in here regarding water reuse, which Israel does quite a bit, and how can that be translated to help the neighbors?
Okay, actually you have here three different questions. Water to Gaza, between Israel and Palestine, and Palestinian and Gaza, water to the West Bank, between Israel and Palestine, and the third one is reclaimed effluents to be used in the region. Let's start with the last one. Israel is the only country in the region that reclaims and uses 85% of the total discharge of municipal effluents. 85%. Every drop of it is utilized by the agricultural sector. I repeat, 85% of the effluents, domestic effluents, municipal effluents, are treated and used by the agricultural sector in Israel. The agricultural sector in Israel, the total amount that they use nowadays is 0.9 billion cubic meters a year almost 1 billion. 86% of it is the reclaimed sewage. 86% is the reclaimed sewage water. 24% is they utilize natural brackish groundwater, and only the fresh water is the rest. Now, unfortunately, the vast majority of the effluents produced in towns and cities over the West Bank are not appropriately treated, and it's not only the Palestinian. It's not that the Palestinian Authority is the only one to be blamed. We have to be blamed as well. I don't want to get into that, but these effluents should be treated. However, as I showed in one of the slides, it is not safe to use this water over the West Bank because this is the recharge area of the aquifer, and we shall never reach the situation of 100% irrigation efficiency or no leakage at all. Therefore, we have to actually make sure that this water will be used either in the eastern part of the West Bank along the Jordan River, where it is safe to be used, or in the northern Negev of Israel. That means we have to move toward water trading. We shall have to emphasize, in my opinion, buying the effluents, treat the effluents, utilize the effluents, and replace it with fresh water to be used by the Palestinians in the West Bank on top of what they abstract from the aquifer. It is for good, for the benefits of Israel and for the benefits of the Palestinians to maintain the groundwater reservoir in the mountain aquifer, not just as the main fresh water source, but also as a backup water supply system.
Yeah, I'll ask one more question. There is a question about conservation of domestic water in Israel, and how does that also relate to use of green energy? And then someone else asked a question about, with all the developments with AI, how is that going to affect water use in Israel? Is there a concern with regard to that?
Okay, I will ignore the AI. I don't think it's relevant for now. Regarding water conservation, there is no country in the world, with all modesty, that the water use efficiency in our municipality is below 10%. 9, 7, 6%, this is on the average. No one in the world has this kind of water supply system, reliable water supply system. Why? Because in Israel we pay for water. Water is not free. We pay for water, although it's a natural resource. Now we manufacture water, and even before that we pay for water. We pay for water as a value, as a source. We pay for transmitting the water. We pay for treating the water. So once you pay for it, you have all the incentive to save on it. So water use efficiency by the municipalities, by the agricultural sector, is the highest in the world, with all modesty. I wish other countries will do the same. It will save a lot. Next question.
All right. So can you get back to, maybe that's the last question, but get back to the issue with regard to water in Gaza and the relationship with Israel, and what does the future entails?
Well, before the last war, Gaza war, even before that, Israel used to supply Gaza with fresh water for the desalination plants in southern Israel to provide the small but still sustainable amount of water for domestic use in Gaza. Fresh water. Why is that? Because in Gaza, out of known about 4,000 or actually 4,300 wells in Gaza, Less than 2,000 wells are official wells. All the others, the rest are pirates, illegal wells. Water level was so shallow, everyone could, not drill, dug, or dig for a well, abstracting as much water. Water abstraction in Gaza was not controlled since the beginning. Under the even before we got to Gaza, and then during the time we controlled Gaza, and after we left, the water abstraction in Gaza was not controlled by no one, and that the consequences, the water levels dropped drastically below Mediterranean seawater, and they started suffering from seawater intrusion, in such a case that the entire, or almost the entire southern part of the coastal aquifer of Israel was polluted, or has been polluted, by seawater intrusion. The situation is so bad and cannot be actually controlled, because, as I said, the water levels are below the water level with the aquifer. In addition, natural saline water from Israel, natural from the Eocene aquifer, to those who are familiar with that, are flowing naturally, like all roads leads to Rome. All water flows into the sea below surface, above surface and below surface. Water flowing from saline, salty aquifer in Israel into eastern Gaza. The solution will be to reclaim the aquifer, the southern aquifer. It is a process that will last several tens of years. Until then, Gaza will have to rely on desalinated water. There is no other source.
Okay.
That is the solution now.
Yeah. Well, thank you, Elon, and we really appreciate the depth of the discussion and the information, and we appreciate the participation from so many countries, from the Åland Islands, from Canada, the Czech Republic, Denmark, Germany, Greece, Israel, Italy, Japan, Morocco, the Netherlands, Poland, South Africa, and from Syria, Turkey, United Kingdom, and others. And again, I want to thank the sponsors of the webinar, from the Center for Middle East Development, Center for Near Eastern Studies, Department of Geography, Water Technology Research Center, the Institute of the Environment and Sustainability, and really to thank the Nazarian staff for putting this webinar and the webinar series together, to Gage Greenspan, Elizabeth Stein, and Maura Resnick, the executive director of the center. And again, thanks to Steve Zipperstein for shepherding this entire series of seminars that deal with such important topics. I'm sorry that we couldn't answer all the questions. There were quite a few questions, and I think that there is a long list of questions. Elon, you could probably write a paper just by responding to all those questions. So we'll send you those questions. We'll send you those questions. You may find those interesting, and perhaps the Nazarian Center may want to put together maybe a document that provides factual information that relates to some of those questions. So with that, I'm going to say thank you to everyone who participated, and we'll see you at the next Nazarian Center webinar. Thanks, Elon, and I guess for your case, it'll be evening, so it'll be a good night, and for all of us, have a great rest of the day. Thank you, everyone.
Thank you very much, Yoram, for